Okay, good afternoon, ladies and gentlemen. My topic this afternoon will be, or this evening, early evening. Oh, I tried to install the input line to this power transformer because this power transformer got so many terminals on the secondary. And I wanted to know what will be the output AC voltages on the secondary after installing the line that goes to the primary of the transformer. So what I did, guys, is that since this transformer here got 10 terminals on the secondary, as an electrical engineer, for us to bring out the voltage to a two terminal, there should be continuity. And I measured the continuity of the individual terminals, okay, by using a multitester. I set it to the ohms setting. So what I have did, guys, is that since there are 10 terminals, there are so many combinations because each time you measure a resistance, there should be two terminals. And for it to bring out the voltage, there should be a continuity. So I started with terminals 1 and 2. Terminals 1 and 2 here. Because this is 1 going to number 10. So I started with terminals 1 and 2 by using the multitester. Okay? And I've done that one a while ago already. The resistance between terminals 1 and 2 is 0.4 ohms. Oh, that's not a short circuit because if I try to check the continuity of my multitester, if I try to check the continuity, it's almost perfect. It's almost zero. It's actually zero. So if I use the two terminals and there came out the value of 0.4, that's the correct value. It's not a short circuit value. Okay. So what I did is that I measured the resistance between terminals 1 and 2, and I got the summary here already. Between terminals 1 and 2, it's 0.4 ohms. I started with R terminals 3 and 8, it's 15.6 ohms. 3 and 8. 3 and 8. So I am taking the resistances with every possible combination. So R38 is 15.6 ohms. 39 is 15.1. There is a value. So meaning to say, if we energize the primary, we could measure a voltage on those terminals because it got a resistance reading. So between 3 and 10 is 15.6. Between 4 and 5 it's 0.5 ohms. Between 6 and 7 it's 1.4 ohms. 8 and 9 is 0.8 ohms. 8 and 10 is 0.7 ohms. 9 and 10 is 0.3 ohms. And 3 and 10 is 15.7 ohms. So if I will try to mark this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 terminals which indicated a resistance value, and supposed to be, if we try to insert or inject a voltage on the primary, on those terminals with resistance value, there should be a voltage. And to give you just an example, I will start with 1 and 2. This is set to the voltage AC, okay? between terminals 1 and 2, the multitester is already connected. So when I insert this one on the outlet, there should be a voltage reading on that one. Okay, I will try to insert the primary now. And the voltage reading is 3.61 volts. AC, alternating. That's 3.61 volts. So actually, if you try to rectify this 3.6 volts, okay, by using a diode on its terminals, that will be DC already. And if we try to regulate that one, we add up a regulator on the after the diode. So after the regulator, the voltage will now be a regulated value. Okay. That's terminals 1 and 2. Okay, I will try to remove this one to be safe. I will try to connect to 3 and 9. Because the resistance between 3 and 9 is actually 15.1 ohms. So supposed to be, there should be a voltage reading on this one. So I will connect the first terminal on 3 and the second terminal on the 9. We are measuring AC voltage, so there's no polarity. We could interchange the plus and minus. Okay, so between 3 and 9, I will try to inject the voltage on the primary again. The voltage is 29.76 volts. 29.76. Could you see it, guys? $29.76. Right? So, on these terminals, if we try to rectify this AC voltage, we could get a DC voltage, right? And if we try to regulate the voltage on the after the diode, we add up a regulator commensurate to 29.76 volts. Okay? Oh, I will try to remove this one again. Then I will go with 3 and 10. First terminal is on 3. Terminal number 10 is the last one here. Because there is a resistance reading between terminals 3 and 10 to 15.6. And let us try to measure the voltage across terminals 3 and 10. Across terminals 3 and 10, the voltage is 59.2. Could you see it, guys? Yeah, it's 59.2 volts. That's alternating AC voltage. So if we try to rectify this one by adding a diode on the secondary, on this portion here, or secondary, we could rectify this one by using a half wave or full wave, it depends. And if we try to regulate the voltage, we could add up a voltage regulator after the diode. That's the purpose of this. That's why I wanted to know the output voltage on the secondary for the combination terminals that exist on the secondary. Next one, 3 and 10. I will go with 4 and 5, terminal 4 and 5. To be safe, I remove the first primary. I will connect the first terminal on 4 and the next terminal on 5. Okay, 4 and 5. Across terminals 4 and 5, there is a reading of 0.5 ohm. And supposed to be, we could measure in an AC voltage here. Again, I will try to insert the primary. The voltage between terminals 4 and 5 is at 12.61 volts. Could you see it, guys? 12.61. Yeah, that's 12.61. So there are actually many AC voltages on the secondary because the terminals are 10. So it depends on us on how could we determine the AC voltage. So if we try to rectify it, we could what you call this pinpoint or use a voltage regulator commensurate to this AC voltage here. Oh, what's next? 6 and 7. Okay, I will try to remove again this one. I will change terminals just to be safe. 6 and 7. 1, 2, 3, 4, 5, 6. This is number 6. And 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Because across terminal 6 and 7, a while ago, I measured the resistance of 1.4 ohms. And supposed to be, we could measure an AC voltage across it. The voltage is 10.36. Could you see it, guys? 10.36. So across terminals 6 and 7, we could measure 10.36 volts AC. So if we try to rectify this one, we add up a diode here, either full wave or half wave. And after the diode, if we try to regulate the voltage, we could add up a voltage regulator commensurate to 10.36 volts. Okay? I will try to remove this one again. The next one is 8 and 9. 8 and 9. Yes, to be safe, I remove the plug. 8 and 9. This is terminal 8. This is terminal number 9. Okay, we are measuring AC voltage, so there's no polarity. We could interchange the black and red. Okay, 8 and 9. A while ago, I measured the resistance between terminals 8 and 9 of 0.3 ohms. And supposed to be, we could measure a voltage across it. Again, I will try to insert the primary. The voltage across terminals 8 and 9 is 29.79 volts or 29.8 volts. Can you see it, guys? 29.80 volts. Okay. The next one, terminals 8 and 10. Okay, that terminal 8. Then this one will be terminal 10. A while ago, across terminals 8 and 10, I measured the resistance of 0.7 ohms. So supposed to be, if we try to energize the primary, we could measure an AC voltage here. And what will be the AC voltage that will come out? The voltage across terminals 8 and 10 is 59.3 volts. Could you see it, guys? 59.3. Okay. That's an AC. So if we try to add up a diode on the secondary of this 59.3 volts, we could change that 59.3 to DC. And if we try to regulate that voltage DC, we add up a voltage regulator after the diode. Next one. 9 and 10. Okay, I will try to remove the primary. 9 and 10. So I'll just change this one to number 9. A while ago, across terminals 9 and 10, I measured the resistance of 0.3 ohms. There is a reading. So if we try to insert the primary, we could bring out a voltage on the secondary. And what will be the voltage supposed to be? Okay, it's 29.82 volts. It's almost 30 volts. Okay, that's easy. So if we try to rectify this one, we add up a diode on the secondary of this 29.82 volts. And if we try to regulate the voltage, we add up a voltage regulator commensurate to this 29.82 volts. Okay, I will remove the primary again. The last one will be 3 and 10. 3 and 10. This will be terminal 3. That's terminal 3. This is terminal 10. A while ago, I measured the resistance of 15.7 ohms, and supposed to be we could measure a voltage across it if we try to insert the primary. And the voltage on the secondary across terminals 3 and 10 is actually 59.3 volts. That's a big voltage. So if you need 40 volts, you could rectify this one, okay? And if you try to regulate it, take a voltage regulator near 59.3 volts. Okay? That's it, guys. That's it. So in here, the summary of the secondary voltage are this one here. I got a voltage of 3.63 volts. I got a voltage of 30, almost 30 volts, three values, actually three terminals. Two terminals times 3. So actually I got 30 volts. I got one 10.3 volts. I got one 12.56 volts. And I got three phases of 59 volts. So there are actually how many voltages is this one? 1, 4, 5, 6, plus 3. Actually, on the secondary of this one here, I got 9 voltage AC in which I could utilize those ones to bring out a direct current voltage. And if I want to regulate it, I will add up the required voltage regulator very near that value. Okay, that's it, guys. So for now, I have determined the specification on the secondary. So just in case, I will try to construct a voltage regulator emanating from these AC voltages, I could do it. That's the purpose of this topic here. Good evening from Los Angeles. This is Professor David J. Delos Reyes.